So today we're taking a look at a block sliding on a ramp. We want to take notes on the energy story of how the energy is going to start out in the block and how it's going to end or how it's going to distribute as the block slides down the ramp. So let's take notes on this. First of all, we've got a title, Block Sliding on a Ramp. Then we have three types of energy. We have G, representing gravitational potential energy, M, representing motion energy. We also call that kinetic, but we want to call it motion to help us understand that this is a large object that is moving, and T for thermal energy. So we start with the block that is on the top of the ramp, but it's not moving anywhere. We've really just essentially been holding it there. And it starts with then some potential. It starts with some potential to slide down the ramp. So we're going to go ahead and put some potential energy in this, some gravitational potential, in the form of G's. And we're going to start out with 8 G's. And that means during our entire work here that we need to make sure that we have 8 pieces of energy, because we can't lose energy or gain energy. It has to go somewhere. And so these are the 8 bytes of energy that we are taking a look at, that we are concerned about tracking. So our block starts up at the top with 8 G's. What happens, of course, is that we let go, and as we let go, our block slides down and gets to about the middle spot. And as it's at the middle spot, is of course moving. It has some motion energy, but it still has some gravitational energy as well. So what we're going to do is say that since it's about halfway down the ramp, then only about half of its gravitational potential has been lost. So I'm going to go ahead and put 4 G's there. Remember, that's half of 8. So 4 G's are still gravitational energy, but the other 4 have changed into something else. So what have they changed to? First of all, we know that our block is moving, so it's going to have some motion energy. And we're going to go ahead and put in an M and an M, because this has started moving. But I'm not putting in all M's, because as our block is sliding down the ramp, we realize that there's a contact between the surface and the block, and through that contact there's a rubbing, and that rubbing makes sure that thermal energy actually goes out onto the ramp. And so that's actually how the block seems to lose energy. So we're going to go ahead and put some thermal energy back on the ramp here. So the thermal energy gets dissipated out. It basically falls out onto the ramp, and so we have thermal energy here and thermal energy here, and then again with our 2 motion energies and 4 gravitational potential energies. So moving along, we go ahead and first of all, we have our thermal energies that are still there. They're not going to move anywhere, because we're just going to say that they're still on the ramp where we left them off. But our gravitational energy is almost completely gone. We're at the bottom of the ramp. Well, not quite. It's still going to move out onto the ground, but we're going to say that most of the gravitational energy is gone at that point. We're going to leave 1 there because the block still has to go out onto the floor. And so we end up having another thermal energy that's lost out there. And I'm going to say that this is, of course, moving faster. This is a faster moving block because it's down at the bottom of the ramp. So we have 4 movement energies. Then we still have 3 thermal energies, and we have 1 gravitational potential energy. So the block is still moving down the ramp. It's actually going to soon be on the ground. So let's take a look at what happens when it moves to the ground. So on the ground, we have our block here again, and the thermal energy is on the ramp. There's also some thermal energy down here on the ground, and so that's 4 of our energies that have become thermal energy, and our block is still moving. So we have our block still moving with 4 movement energies, and of course it's going to slow down from there.